All right, welcome back. Today, we're putting on our hard hats and becoming digital architects. We are going to lay out the advanced blueprints for building a seriously secure, resilient, and massive network on AWS. So, let's just dive right in, shall we?
So it really all boils down to this one big question. How do you actually build a secure, interconnected, and resilient empire in the cloud? If you want to move beyond just a basic, simple setup, you've got to start thinking like a city planner, right? You're designing this digital empire that can grow, connect, and, withstand just about anything. And that's exactly what we're going to walk through.
Okay, first things first. Every great empire, every sprawling city, it all starts with a single plot of land. And for us, that means we've got to establish the fundamental boundaries of our digital campus before we can even think about building.
So what is this plot of land? Well, it's your virtual private cloud, or VPC. Just think of it like your own private, completely fenced-off piece of property in the huge, sprawling world of AWS. It is your exclusive space. You control everything that comes in, everything that goes out. And this isolation, it's literally the first and most critical layer of your security fortress.
All right, so inside this plot of land, we've got to organize our space, right? And we do that with a few core building materials. First up, you have subnets. Think of these as your individual buildings for different departments. One for your databases, another for your web servers. Then, to connect all those buildings, you need roads. That's where route tables come in. They control the flow of traffic. And of course, you need a way to get in and out of your property. That's what gateways are for. They're the main entrances and exits to the outside world. And finally, AWS has something called service quotas. You can think of these like the initial zoning laws for your city, telling you how much you can build, say 5 VPCs per region, right at the start. Okay, so you've built a few of these isolated properties. That's awesome for security, but they're not super useful if they can't talk to each other. So the next big challenge is connecting everything. We're talking about building the bridges and highways that'll turn these lonely outposts into a single, thriving, interconnected metropolis.
So when it comes to connecting your digital buildings, you've basically got two main choices. On the one hand, you've got VPC peering. This is like building a simple direct bridge between two VPCs. It's perfect for a one-to-one connection, no doubt. But what happens when you have dozens of VPCs? Yeah, that approach becomes a tangled mess of bridges really fast. That's where the other option, Transit Gateway, is a total game changer. It acts like a central transportation hub for your whole city, simplifying all those connections and managing all the routes from one single place. So much cleaner.
But what about connecting your new cloud city back to your physical HQ? Well, here again, you've got options. You could build what's essentially a private monorail using AWS Direct Connect. We're talking a dedicated, high-speed, private physical link to AWS, perfect for heavy, consistent traffic. Or you could use a site-to-site VPN. I like to think of this as a secure, armored convoy that travels over the public internet. It uses heavy-duty encryption to keep all your data safe on the journey.
A great city isn't just about how well connected it is. It's about how well it can handle a disaster, right? Whether it's a massive storm or a simple power outage, your digital campus has to stay online. So now, let's get into building for true resilience.
And this is the absolute core principle. The goal is simple. No single point of failure, period. Think about it, a structure that relies on just one single pillar, it's going to crumble. Your goal is to build a redundant system so that if one piece fails, the whole thing keeps right on chugging. An outage needs to be a minor inconvenience, not a business-ending catastrophe.
So how do we do that? Well, it really comes down to these 3 key steps to building in that fault tolerance. Step 1, a multi-AZ design. You have to deploy your subnets and your resources across multiple availability zones. Think of AZs as separate independent power grids for your city. Step 2, NAT gateway redundancy. For any resources that need to talk to the internet but shouldn't be publicly exposed, you use a NAT gateway. And the key is you put one in each AZ. And third, endpoint redundancy. For private connections to other AWS services, maybe like S3, you use endpoints. And you guessed it, these also need to be set up in each zone you're operating in. You do this, and if one entire zone goes down, no big deal. Your traffic just automatically reroutes through the others. It's beautiful.
Okay, we've covered the foundations, the connections, the resilience, the fundamentals are down. Now we get to the really cool stuff. These are the advanced blueprints, the techniques that separate a good architect from a master. We're talking tools for ultimate security and truly massive scale.
And this quote right here, it just perfectly captures the magic of a service called AWS Private Link. Just imagine for a second. You need to connect to a service, let's say S3, but you have a strict rule. Your data can never, ever touch the public internet. How do you do it? Well, PrivateLink creates a secure private endpoint right inside your own VPC, basically teleporting that service to you. It is the absolute ultimate in secure connectivity.
Now, as your organization grows, maybe into hundreds of teams and accounts, things can get, well, chaotic. It's a mess. Shared VPC is the elegant solution to this problem. It lets a central networking team own and manage all the core network infrastructure, and then they can just share out specific subnets to different application teams. This is huge. It centralizes control and security, but it still gives your development teams the agility they need to actually get work done. Best of both worlds.
So, we've built it. Our city is vast, it's resilient, it's all connected. But let's be real, a city without a control room, without air traffic control, it's a city on the brink of chaos. So now we have to talk about how we actually monitor and manage this sprawling digital metropolis we've just created.
And this really is the million-dollar question for anyone managing a network, isn't it? I mean, with all this activity, with data flying between buildings out to the internet, back to your HQ, how in the world do you see everything that's happening? How do you get that bird's-eye view to spot problems before they turn into a full-blown outage?
Well, luckily for us, AWS gives us a pretty powerful toolkit. First, you have VPC flow logs. Think of these as traffic cameras on literally every single road, logging all the data so you can see exactly who's talking to whom. Then, for troubleshooting, there's the reachability analyzer. It's like a GPS for your network. You tell it to trace a path from point A to point B, and it'll tell you exactly where a connection is getting blocked. To manage all your IP addresses, which can get out of hand fast, you have IPAM, which is basically your city's official address book. And finally, and this one is so important, tagging. You have to label everything, every building, every road, every car. It's how you track costs, ownership, and make automation possible.
All right, there's one last crucial step for any good architect, and that's maintenance. Because without it, even the most beautiful, well-designed city will eventually fall into disrepair. And in the cloud, we call this digital urban decay. The fix? Cost optimization. You got to prune away what's no longer needed.
And here are some of the biggest culprits. You've got idle elastic IPs. That's like paying property tax on an empty lot you completely forgot you even own. You've got unused NAT gateways. Those are super expensive bridges that lead to nowhere. And don't forget costly data transfer between your different AZs. The key here is active city planning. You have to regularly scan for and, demolish these wasteful, abandoned structures to keep your whole metropolis lean, efficient, and totally cost-effective.
So there you have it. That's the blueprint for building your own digital fortress in the cloud. But you know as well as I do, technology never ever stands still. The amazing architecture you design today might not be ready for the challenges of tomorrow. So the real question for you, the master architect, is always, is your world ready for what's next?